There you go. Go ahead and get started. My name's James Mihm. I'm with Intel, and I'm the BMC firmware team lead, and I work on all different aspects of the BMC firmware, not just with OpenBMC, but that's been something that I've wanted to have happen for a long time, so I'm glad to be here and glad to be part of this. So I want to do a quick introduction for those, the two or three people that don't know what a BMC is. That BMC is just a management interface to the host that provides health monitoring, eventing, logging, and with LAN connectivity, you get out-of-band access. One key thing I'll skip that one. So this is a typical server block diagram for an Intel server. One key thing I wanted to mention here is that the BMC is really three components integrated into one. There's the VGA controller. That's where we get the connectivity for being able to do KVM. We have the Super I/O chip that's in there that provides all the host interfaces into the BMC. Then there's the BMC controller itself, which is an ARM-based device. It's a high-level block diagram for the I2C bus topologies that we have. We have power supplies, storage backplanes, and all the other cool stuff. So, pretty typical diagram for most people. I want to go over, in order to talk about the journey, I want to talk about where we came from. So Intel has over 23 years of experience in this field. Starting off with add-in cards that would plug in and be a cable down to the baseboard, very expensive solution. And the migration through here was to go down, get it onto the baseboard. And back then in the early days, the end goal was to get the manageability into Intel Silicon, which was achieved with the ESP2. Then of course, what was interesting was that might have been the wrong path to take. And then in 2006, we migrated away from going into Intel Silicon into a discrete BMC controller. And we did that with the Pilot series. And then the ME was also introduced into that, but that's a different topic. One thing that I want to point out with this history is that every one of these, this 6 different generational changes in which each step was a huge effort. You know, change the microcontroller, change the firmware stack. That's big lift. And what was good in the early days, that was what we had the same team doing it, so we could always leverage the tribal knowledge from one generation to the next and make improvements. And some of those can get torpedoed when you have a mass migration of developers that do leave your team for whatever reason. Then you lose that tribal knowledge in history. So that's one of the goals here with OpenBMC, is that we get that tribal knowledge spread out, and got a good record with that. The history with all the check-in logs and discussions that go on. Share the knowledge so that more people get to understand why we do the things that we do. So why Intel with OpenBMC? Because customers want it, and they have a right and a need for it. Being able to have customers being able to look at the code and debug problems in their data centers is huge. Whenever you've had problems with customers, it's been my experience where they have a problem that we can't reproduce in our labs, or we fix it, we think we have it fixed. Then the failures go from happening in a couple of hours to a couple of days or a week. And not being able to share the code because it's licensed and they would have to go get that license, it becomes a non-starter for most customers and they get upset. Doing open source, that argument goes away and we could all talk out in the open about stuff. And I think everybody's already hit on this, the shared efforts that we're all doing the same things, doing the same kinds of sensor monitoring, and a lot of duplication of work. And there's really nothing proprietary about how we're doing fan speed control and how we're getting temperature sensors and That's not where the fun is. Working with ODMs and giving them a toolkit to work with is a big advantage for us. And I think I've heard from everybody talk about that. One thing that, like Brad has pointed out to me several times, like the OpenBMC is a toolkit for everybody to use as a starting point. And that's a good toolkit to use for doing reference implementations for any open standards. With Redfish, it's an obvious example. Anything that OCP comes up with, they could use the OpenBMC as a toolkit. I put this together to show, do a comparison against what we've done traditionally in development. On the left-hand side is all the third-party hardware vendors, BMC vendors. You know, they all have to interact and communicate with all of the BMC firmware vendors and the server providers such as Intel and Supermicro and anybody else that's they want manageability for their parts. So there's a lot of touch points and there's a lot of duplication of effort going on there. Where on the right-hand side, the OpenBMC project kind of becomes a focal point where people can share their efforts. We can save time in development because the content experts for their products, the hardware vendors for the add-in cards and stuff, they have a toolkit that they can run with and add the manageability for their devices. And once they get that ready, they upstream it into the OpenBMC project, and we all get it. And they have more control over their destiny on getting things out there in the field. They don't have to wait on, you know, hardware vendors being able to find time and get a developer and get that integrated in. So that's the big win for us. Some of the goals, I hit on it before, was faster response for getting things out in the community. Lessen the burden for each BMC firmware development team. When somebody else that knows that product best can add the manufacturability for it on their own. Reuse is the obvious one there, where everybody can reuse the source code that they contributed to. Using the OpenBMC, the community with OpenBMC, we can help get the BMC hardware vendors. We can help support them getting their products out and getting their features for their devices working. You know, they usually produce and put out with their SDK a reference implementation, which is normally inadequate for products. And this would be a good place for them to facilitate them getting reference code out there for their features on their hardware that would be usable by a wider audience. Yeah, I mentioned here manageability, commoditization. That's kind of what I view what we do. Is the basic manageability is like, it's a commodity item, like everybody's doing the same thing. And as a BMC developer, that's not where the excitement is. You don't want to redoing fan speed control. You know, most people, you know, once you've done it once, it's good. But after a while, you don't want to keep redoing it because you've changed microcontrollers and changed your firmware stack from one vendor to another. It kind of becomes grunt work at that time. It's not exciting. One goal I'd like to see is having common interfaces across different server vendors for doing provisioning, firmware updates, and Redfish will help us get there too, but even going beyond that, on the host interface side. I can imagine, I just have this picture in my mind in the data centers where when you're managing a data center, if you have 6 different vendors and you have 6 different firmware update packages, 6 different configuration tools that you have to manage, that becomes a nightmare. So I want to try to lessen that burden on them. Transparency. I like the idea of transparency where everybody gets to see things that what you're doing. Security is a big one there, where it's easy to hide things that are security vulnerabilities if you don't let people look at your code. Then they have to go and peek and poke at it, and they might run into it. One of the things that I've observed already is like the broader range of the viewpoints that everybody brings. People bring up ideas that we haven't thought of, and some ideas come up that we've already thought of. We did it and we went away from it. But you get that broad range of viewpoints where we could all share with everybody. And of course, the freedom and choice for customers, where they get to pick what they want in their distribution if they're doing their own implementation. And that's one of the advantages of using Yocto for that. And then, of course, ODMs and even customers being able to customize the firmware, even if it's as little as the embedded web server. They want the look and feel that has their signature on it. They can do that. A lot of times, if somebody wants customization, they got to go to your firmware vendor, or they come to us for it. And we're not set up to do that for a large scale. If you're doing an open source solution, they have the option of doing that themselves or contracting it out. This was just to illustrate the shopping list with Yocto, picking the recipes that you want, and being able to use Yocto to fine tune and run patches is an obvious thing. The vendor opportunities, this is where I'm glad to see that AMI is on board with this, and the role that I hear them taking is exactly what I figured a firmware vendor would want to do. They'd want to be doing long-term support for customers. They could add value there. Because a lot of customers aren't going to want to do the firmware themselves, or if they're not the right size, they can hire somebody to do that. I think of it as the Red Hat model for Linux, where they're taking a snapshot, validating it, adding any features that are required for their customer, and doing a distribution that will fit their needs, and then supporting that. Because I don't think anybody in the OpenBMC wants to support long-term everybody's products out there. And the other vendor opportunities are hardened BMC security, not just in the firmware, but in the hardware. So when I hear about Cerbis, that functionality, it's like, wouldn't that be nice if that was in the BMC? The BMC had all the cryptographic TPM type functionality that on power on reset, it can go off and do all of that authentication or validation, all the crypto checks, make sure the images are correct for running, and the key management and doing that securely. And it was announced for Intel products that we have the PFR, which we like that as part of our secure boot. That's our. Once we get that fully engaged, that saves us on the BMC firmware side from having to do secure boot. We'll still do secure boot for a while, but that's the real check and the real protection, and having the fallback mechanism to recover from any vulnerabilities that were impacted us. Talk about some of the challenges. So for our team, doing open source development is new. We're new to it, like Brad was explaining it on his case. We're in the same boat. We're new. We're figuring our way around, learning as we go. And we got some good mentors from IBM that are helping us. And we got open source team at Intel that helps mentor us too, so to make sure that we're doing the right things right. And but that's a learning curve. And then one of our biggest challenge I think that we've experienced is trying to deliver on our internal schedules and our internal timeline while trying to open source, because open sourcing takes time. And what normally would take us a week or two to do internally, I've heard different numbers. It could take anywhere from a month to 3 months. And of course, when management hears that, they cringe and find that unacceptable. So that's something that we have to work on internally, and we are working on that. And in part of that is, like internally, we're doing code reviews internally. We have a GitHub repo internally. It pretty much mirrors what's out there in the OpenBMC community. So we're doing all these cycles internally. And then once we think we have it done, to open source it, we kind of go through the same cycles, which is kind of redundant, and we need to try to eliminate that. So that's some process stuff that we have to tune on our side, some of our challenges. And of course, unit testing. Part of the continuous integration cycle in the community is like it'd be nice that when people are checking in code that things can get validated on an x86 platform, either at Intel automatically, so when somebody breaks that, they get notified and we don't have to find out and then go and complain about it. Same thing when we make changes, that we can find out ourselves that we broke something and fix it before somebody else notices it. So that's an area of improvement, which I hear there's some people that want to work on that. Aligning product level requirements. That was one of the things like Ollie mentions, like trying to align in the open community the feature sets that we want to have done and what other people want to have done. If we had like a roadmap for our desires, and we've talked about this, that we want to try to publish what the features that the project can be working on, and try to align, try to get alignment with server vendors that when these things can get worked on. If, like KVM and remote media are the two big ones that I worry about, because nobody I'm aware that is working on it. So when I saw the slide from AMI, I thought they were going to open source that, and that was going to be cool, but I don't think that's going to happen. But there are some proof of work concept out there for KVM for Midnight Engineering, but it's not baked yet, and we need to try to pick up on that. Yeah, security. That's one of my focuses at Intel is security. So that's what, when I look at the security in the OpenBMC project and I don't see it, that's when I cringe. And so I see the project happen, or the way the project got started was the same way as any project I've been on, and security is kind of an afterthought. And Andrew talked to it too, but we're actively trying to get that taken care of. I think everybody wants that resolved. So secure boot's one aspect of it, firmware signing is one aspect of it, but all the runtime checks and detection of when somebody's corrupted your configuration and you're under attack, that's an area of improvement that we can make on. So hopefully there'll be a lot of working groups there trying to harden the BMC firmware on that aspect. In process isolation, we've already got that started. We just need to keep that continued and take a look at everything. We've talked about SC Linux and having access control lists for different applications, so that applications are running at the least privilege they need to get the job done. They don't have access to the whole file system if they don't need to. Those kinds of things. Probably one of the first places that we need to start at here is going to be doing a threat model and analysis, and that's something I'm going to try to pick up here. So if anybody wants to participate in that, give us a shout, and you can help out there too. One big challenge that I've already run into is on the penetration testing is like in sharing results. It'd be great for all of the different companies that are involved. I'm sure everybody's going to have their own security validation teams, and they're going to be doing penetration testing, static analysis, and it'd be great if we can share that information rather than keep it to yourself. That's my intent. Is I want to share everything I get, but I got to follow within our guidelines and the license agreements we have with the tools, because in some of the tools there's license restrictions that you can't publish what the reports are. So I got to work with our open source community to figure out what do we do in this space. One of the suggestions was to use Coverity from Synopsys for doing open source static analysis, which would be great. Then of course everybody's going to have their own requirements around like the penetration testing. When you find something, how do you react to that? My first thought there is, well, fix it first. Then once you got it fixed, share it, and then. But we'll have to follow any guidelines that are put in place for us there. 1 minute. Oh, come on. Okay. And then the typical get involved. Everybody knows. That's it. I mean, you've all seen it. So one thing is that we're planning on hosting a hackathon at Intel in Hillsboro. I was hoping to have the dates set in gold before this conference, but I didn't get it. But it's tentatively scheduled for in September. So just to let you know, as soon as I can get back and start knocking on doors and getting those dates solidified, I'll send it out on the mailing list, put it out on our web page now, on the blog. Get on the blog. Okay. Any questions?
Okay.
No, my question's not a real question. I was asking how you didn't make it GIT involved as a fun. That would have taken all of my willpower.
Do what?
To make it get involved with an I.
Oh. Thanks. Oh.
All right, thanks, James.